Hey everybody, let's start our meeting. It's October and you're looking at a picture of one of Johnny Mac's projects, the electronics. And today we have no particular agenda, but Chip has some important work he's been doing on the tools relating to the file system that he's going to show us. And then we can talk about anything else, or during that interrupt him with any questions we've got. Sound good?
All right, should I just start talking?
Yeah, what do you got?
Okay, so I've been working out a file system. Let me share my screen so I can show something. Advanced, a portion of the screen. Here it is, over here. So, okay, let me pull this thing out. So I have here a file. I'm modeling the file system that Tom and I were working on when we had that last meeting. So I'm modeling it inside the P2 because we've got plenty of memory. We don't have 16 meg, but I reorganized it so it's just a 256 block file system with 256 bytes per sector. So it takes 64K to operate. And the point is to kind of work out wear leveling algorithms and make sure that we can survive power downs. Although that's kind of hypothetical in the context of RAM, but we've come up with mechanisms so that we can survive a power down at any point during a file modification, so that at most you lose your new save, but you still have your old save. And so in the course of doing this work, I've realized there are some things that I don't like about spin. That it's not really that I don't like exactly, but things that could become more efficient. Like you see expressions like this. That's not even a good one. Let me find another one. Sometimes there are these really complicated, like this. Look at this. Right? So that's a byte pointed to by this, ID to block lookup. Oh, but then run through this thing called BP, which comes up with the block pointer, based on the ID to block table. And then this is saying, I want byte 4 of that, and I want this bit field, 5, 6, 7, the top 3 MSBs. So a lot of these things, I have to, type this a couple of times to get the job done. But what I did is I made this thing where you can go like this. You can say, let's call this just P for pointer. Pointer equals, now this is always returns the address of something in hub memory, but you can't do that when you have a bit field like this, because it's no longer just a byte word or long offset. It becomes more complicated. So I have this new thing that it's caret at, and what that will do is it will put into P a kind of a 32-bit descriptor of, is this a register? Is it a byte word or long? Where is it at? And what's the starting bit and the ending bit? It just so happens that fits into 32 bits perfectly with a 20-bit address map in the P2. So once you have a pointer set up like that, if I want to do all of this, all I have to say is I just have to go like this. And that will take P, which is this complex field pointer, and it will, turn it back into a proper register address or hub address with, whatever the bit field is. And then what you can also do in this thing is you can put an index in here, and that can be any number, of course, but what it keys off of is the word size. If it's a byte, it's 8 bits, word 16, longs 32. But if you specify a bit field, like this is a 3-bit field, right? You got bits 7, 6, and 5. So the index here is going to step in units of 3 bits from this base. So it's possible now to make data tables that are like just about any arbitrary bit size. And in the case of using a long, I just made this up before the meeting started, but you see this here? Here we have 1, 2, 3, 4 bytes, right? This will all get read in a read long. And you could read 4 bytes at any offset. You could read 4 bytes from here. But if you look at this 25 bits, this is significant because this is like the biggest bit field you can do at any offset without any fear of losing anything. Because as I step this around here, see, it's always fitting into 4 bytes. Even in this case, it's 4 bytes. It's the last bit of this byte, or excuse me, the LSB. Actually, it'd be the MSB, by the way little endian works. But anywhere you move this thing, a read long, if you have a long variable, you can read 25-bit fields in sequence anywhere in memory. And then for a word, it's a little different. You can overlap, I think, like 9 bits can be anywhere. But if you're doing like you can always do like 24 bits or bigger numbers that are, say, multiples of nibbles, 4 bits, because those will always wrap nicely. But when you get into odd numbers of bit fields, then odd numbers of bits in a field, then it becomes kind of touchy. But anyway, this lets you do all kinds of neat indexing where you can build tables of any bit size in case you wanted to conserve memory for something. So any questions on that or complaints? This was kind of controversial when I brought it up on the forum, but I've since changed the semantics of it so that it doesn't impinge. At first, I just made the at thing do it all because the upper 12 bits were kind of undefined anyway, but now I'm actually clearing those and to get a block pointer. And it's very fast to do this. It's like, 2 clocks, 4 clocks of instructions, 2 instructions. This takes about 19 instructions, but this will do a whole bit field.
I have a quick question. In your example, you're showing a 3-bit field, and presumably index represents like n times. Like if that index was 1, it would be the next set of 3 bits.
Yeah, which will go into the next byte.
Right. What happens if the bit field that you're referencing is larger than larger than half of the data structure that you're in, and then you index to 1? So you overflow your.
Yeah, well, for a long, that won't happen. For a byte, it's tricky. You can really only index a byte infinitely with 1 bit, 2 bits, 4 bits, or 8 bits, right? But when you get to a word, because you can read hub memory at byte offsets, you can go anywhere from 1 to 9 bits and never miss anything. And longs, you can go 1 to 25 bits. But like with a word, you could always index 12 bits because that's always going to hit, byte boundaries. You're not going to be wanting to go 1 bit over on one side and 1 bit over on the other side, making it too big to read at once.
So it's not going to read into the next word.
This actually would. This would move to the next byte if because this is the top 3 bits of this byte, right? So if you index 1, this is gonna become 5, and this is gonna become 2.0.
Okay.
But yeah, you have to be a little careful. You can't just do anything. You have to work it out in your mind. And there are some fast rules like 25 bits for longs, up to 25 bits, but otherwise just got to think about what you're doing.
Is it possible to actually cause an exception or an error of some kind, or would you?
No, there's no runtime checking of anything. It just runs.
So you just get weird results then if you kind of break the rules.
Yeah, like if you were indexing a byte, like if you had a 9-bit field in here and you were using byte, well, it would never fit in any case, right? But you'd always be getting 8 bits from some byte. But it wouldn't be operable. But if you change this byte to a word, that would work at 9 bits.
Gotcha.
Yeah, now okay, let me.
I have a question too, Chip.
Yeah.
Your square bracket P, if first of all, I have to assume that that's an incomplete statement there, the P index, that you're going to do an assignment or something with that value or test it.
That's right. Yeah, you could do something like this.
Okay, good. The square bracket P, technically, I can have already address of something in the variable P, and the same syntax is the accessor. How do you tell then? Are you inspecting the contents of P to see which form of index, whether it's a real pointer or this new index?
Okay, now do you mean from a compile time standpoint or runtime?
Well, you tell me.
Okay, so there's two things that happen here. At compile time, the syntactic rules are such that if you just see a straight bracket, like a left bracket, that's the only place it could occur, because in other times, you're going to have some kind of keyword in front of it, right? So you're going to be expecting a bracket. So if you find an unexpected bracket, it means you're doing one of these. Okay. Now, I did have a word, I was using field, just as a keyword to trigger this thing, but I realized it wasn't really necessary, just as extra typing. Because if you have, long, byte, or, reg, well, this is like universal. It doesn't even need any descriptor, because at runtime, P is holding your data. And I'll show you what that looks like.
Before you go further, isn't this contradicting something you said earlier, which says that long byte and word are optional because you already understand the length?
Well, you have to, as far as the indexing goes, you have to be aware of whether you're dealing with bytes, words, or longs, so that you don't overwrap or,
Yes, I understand that, but my question was, if P contains just a regular pointer, not your new pointer, and you wanted to take the value of that, didn't you suggest that long byte and word are optional in that case? Because the variable is already declared with the length?
Okay, I'm not thinking what you're thinking yet.
Okay, that makes sense. If you declared a word variable, say X, and you take the address of X and put it in P, and then I
Okay.
want the value
For
of,
example, if I just said like at X,
correct.
right, okay.
And now, and X was declared, say, as a word, didn't you suggest that accessing the value pointed to by P already knew that it was going to be a word type?
Okay, yes, but because it was captured with this is agnostic. This only works for hub memory.
Yes.
And this, though, when it sees this, it builds this.
Yes, understood.
You
But
see this here?
yeah, that's wonderful.
Okay, so
What my point was, though, you suggested earlier, just as we started this question, that having the long word and byte removed from the left of the square bracket tells you it's this new style. But you're also telling me that I could access P without the long byte or word, in this case with the address of X, without the the tick there, and it would still do the right thing.
well, okay, if you just say this, right?
Yes.
It's going to return a 20-bit value with zeros all up in these bits. So what it's going to look like is a register of length with 1 bit. A 1-bit field in a register is what it will look like.
Right. My point, though, is I'm coming at this from, I probably should have said that early, syntax parsing and understanding what to do, what the instruction is doing, and a readability. And
right.
So when I see square bracket P, the line below where you are, I'm going to wonder what that's doing. And for me to figure that out, I'm going to have to read lines above to understand what it means, me reading the code.
Okay.
For you having field in front of it, that actually tells me without going to lines above what you're intending as a reader of the code to happen.
Right. Yeah. So if we had a keyword like this
right.
helps
There's
clarify.
a side of me, while you say you don't need it, there's a side of me that says that's actually more educational and more training than it is without it. And
wasn't caret and then the square brackets the thing at one point?
That would work because the caret ties to the previous caret. I could be okay with
Oh yeah,
that.
no, that's how I originally had it. I had it like this. The trouble is when you want to make a new pointer from that pointer, you wind up typing this.
It looks like a little smiley, like a happy one.
Like this.
It's a shrug.
Yeah.
Actually, no, I see these carets as the eyes, but presumably that's just them. You could interpret it as a shrug as well. Yeah, it's kind of both.
Yeah, I mean, if it's, this would be better, I think, right? Or this is good too.
Well, yeah, what I think you're.
Wait, but why would you take another
I'm trying to
pointer of something that's already a pointer? That's slightly
Right.
pointless.
Because if you're doing some kind of linked list or something, you might want to update what is a base variable pointer to what your current pointer is.
Right.
So you don't want to, you want to subsume the index into the 32-bit overall field pointer.
Ah, yeah, that's
You're saying the current
probably a
value.
good idea. Instead of just adding it onto something, that probably is better. Because
Yeah,
then the
just-
add can overflow and everything goes bad.
Yeah, reconsolidate.
Right. So I still don't think I have an answer to my question, and that is, haven't you created a confusion by not having something in front of it? Because the long byte word is optional when you're indexing hub memory anyway.
Because in this case, if you see a bracket where you're expecting like the beginning of a term,
Yes.
then you know that whatever's inside that bracket is going to be one of these field pointers.
Yeah, I understand that. But couldn't I write with P defined the way you have it right now?
Oh yeah,
couldn't
that's
I
wrong.
say-
It would have to be like this,
No, without doing that, I'm saying, I'm trying to talk the case without the field.
like this.
Yes.
Yeah,
Isn't that a legitimate statement even without it?
it is, but but if you look at the encoding for this, it would satisfy this one where S and B are 0 and the register 0. So what it
Yes.
would be is like bit 0 of register 0 in the cog.
And then it corrupts the register and everything stops working for mysterious reasons.
Right.
Yeah,
So,
yeah, that could happen.
yeah, so kind of my point is that I can create a statement that looks identical with P being two different values, and it'll have two different behaviors. And as a reader, I won't know that.
Yeah, you'll have to, well, yeah, my assumption is that if this is present, this is going to be a field pointer. It's not going to be just a 20-bit address.
But as a reader learning spin, how am I going to know to look for that as a field access versus a hub access?
Well, okay. I don't, you realize that maybe this doesn't speak to what you're talking about, but see that if the top two bits are 0, it doesn't highlight here, but that means reg. 01 is byte, 10 is word, 11 is long.
Right.
Right. So it would know.
Well, I understand what you're doing inside at runtime. I know what you're doing there. So I'm talking cognitively for the reader of the code. Sure, you can understand it, but how does the reader learn this technology very quickly without causing confusion in their mind when they read the code?
Hey, can
Yeah,
I
because-
make a comment on this?
Yeah.
Please.
So I think the difference between the two of you here is best summed up by Chip's statement. It's a lot of extra typing, which is a true statement. But the corollary to that is it's much harder to read, right?
Yes.
So,
Yes,
and
that's my point.
the thing is this code is only going to be written once, but it could be read for centuries
That's
or
right.
millennia, right? I mean, you write stuff once, but lots of people, might read it. And you yourself are going to read it 10 years from now, and you're going to wish you disambiguated it.
Well, we could do something like this. We'd have to put some kind of keyword there, or maybe a caret. But the caret does get kind of ugly. This is less ugly if you want to take another address.
Yes.
I mean,
It does
doesn't
take up another
having-
keyword.
Yeah,
What,
doesn't
Ada?
having a keyword not only disambiguate it for the reader, but also for the compiler? It seems to me that it's valid syntax for both definitions of P that have been discussed. So it's ambiguous what the meaning of P is to the compiler, right?
No,
It's
I
not.
see. No, because it's a semantic thing that if you are expecting a variable or some keyword and you encounter a left bracket, because of the way the syntax flow works, you know that this has to be a field reference.
Right.
Well, wait.
So what would
yeah.
what would the compiler error state for the case that P is defined as at X?
It wouldn't even know. It's all runtime.
Well, see, then that's ambiguous because at compile time you get no warning and then the behavior is not what you intended.
Yeah, we'd have to get around problems like that, we'd have to start, you know, strongly typing the language and putting a lot of things in there, where then we start needing a lot of, what do you call those things that convert from one thing to another? They're
Typecasts.
Oh, I hate
Well,
typecasts. Yeah.
Chip, I could state that a little differently though, and that is that you as the engineer or the designer of the compiler can see through to what is essential to make a very efficient compiler. And so it makes good sense that you would try and remove everything you don't need to make a really efficient compiler. I think there's a cutoff before you get to that point where there's a threshold.
Remember that Chip writes the spin compiler in assembly language.
Right. No, hold on. Don't introduce another thing. Let us get through this first, Ada. I know where you are though. I think there's a threshold below which you decrease readability and above which it's better for the human reader as you're heading towards the most efficient. And so what I'm asking for is that you consider, don't cross that threshold, make it easier for us to read it, even though it's less efficient for you and more typing. Does that make sense?
It does, yeah. So that would necessitate probably something like field.
Right. And it also allows us to then see that in our syntax highlighting that, hey, that's an operator or something that's telling us, right? It looks like a function call. So in syntax highlighting, it's actually going to call your attention to you doing something special there, and it's built in. And so it allows us to give us more information to the reader visually as well through color.
Yeah. On the question of, and I don't think there's a difference, but just in case anybody isn't following on whether the compiler gets confused or not, like basically what Chip is describing is there's a special keyword that is nothing before a left bracket.
Correct.
Right? Like,
Yes.
it's like the magic invisible keyword.
And I'm really having a hard time highlighting those magic invisibles.
Well, it's kind of like, what if you had to do something like this? You know, there are some things that are just implied, right?
I think there's some languages that do kind of work like that.
Yes, of course.
Or at least have,
No doubt.
I do know once that they like have, where like you write the if statement as a function. I think is it CMake configuration files where you do it like that? It's the most horrible thing ever.
Everybody loves make syntax.
Oh my gosh, don't we?
Everybody likes what? I didn't catch that.
Make syntax.
It's a build tool.
And I'm not.
Build system.
Oh, right. I don't. You know that. Yeah.
And I also wanted to comment. I believe it was Ada that said, "Remember, he writes it in assembly language." Is that right, Ada?
Yes.
Yes. You can actually see it on GitHub.
No, that's not what I mean. Okay, I just wanted to make sure it was you that said it. And I don't mean any judgment to you or Chip in this statement, but I'll just point out that that is a choice Chip himself made.
I mean, he probably has some Stockholm syndrome because
I'm just saying.
I think he doesn't actually properly know C.
Oh, I wouldn't write it in C.
I mean, these days you wouldn't write it in C, but long days back when the original spin compiler came along, you probably would have written it in C.
Yeah.
So
maybe
these
days you'd probably write it in, I don't know, Rust or something.
No, yeah, definitely not Rust, not my thing. Anyway.
So just to wrap up just to make a final thought, Chip, I'm applauding you're doing this. I'm just heading for, can we increase readability and make a better highlighter?
Right.
I'm raising my hand in your camp.
Yeah. And this does not, I mean, if we leave this here, that's fine. In fact, that has utility because that only returns the lower 20 bits. Look how nicely you could add it. You know, it would affect like that.
Correct.
So it allows pointer math on, register and hub. Like if you have a bit field that's in the out bits of a register, well, you could say the pointer -2 and go down to the DIR register.
Right.
For that same bit field. So it's really nice that we have two separate things, as it turns out.
That's fun.
Yeah, and I here's the code. Let's see. When you make a field, right, it has to let's see. This analyzes like the current variable read-write setup, and it builds these fields out of it.
Mhm.
So whatever's going on, it determines, it makes this 32-bit pointer. And then down here, it takes this 32-bit value and converts it into whatever's appropriate and sets up all of the reads, writes, and the, whatnot. And then down here for the index, this is the monstrosity. This is what I'd like to make simpler, but because I'm having to juggle all these like 25, 5, and 2-bit fields around, it just winds up being a little stringy.
Why
But
is there a QMAL with no instructions in between?
it's 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 19, 20, 25, 26, 27, 28, 29, 30, 31, plus it's going in and out of hub. So there's a lot of clocks there.
Yeah, but that get QX, you could move it down. Sorry, I can't stand seeing code that's bad.
Oh, right. When do we need it? Oh, let's see. We only need, we need the X right here. We need it pretty soon. We
It's
need
the
it-
Y, it gets the Y.
Yeah, the Y. Good idea. That's a great idea. Okay, perfect. That's a good optimization. So that way we don't wait early for the Cordic up here. We wait less time down here when we need it. Yeah, good. I'm glad you pointed that out.
Well, you could even move that use one instruction down.
Yes.
And I think you could move actually the whole XY computation, and that you can actually move that W thing. You can move that, all the manipulation of W can be moved up as well.
Right.
Sorry, I wrote the code that does this in FlexSpin. Basically move stuff in between get QX and I've spent way too much time thinking about what
Yeah,
can
this
you
can
move where.
certainly go there. This can certainly go there. And then that would bring the get QX down, or get QXY would be down to here. Whoops. That would come down to here and it would go away from here.
You can get the entire if 00, if not 00W stuff up down there. You can actually, no, wait, you have to add Y to W first. Okay, that doesn't work.
Yeah.
What's that doing down there anyways?
Maybe I could do, let's see now this. Yeah, see, the trouble is the index affects both the bit field, it affects the base bit field, which is 5 bits, and it affects the 20-bit address field.
Right.
So we need to do that.
I mean, you see what's already concern was with implementing stuff in FlexSpin and making it the default behavior for everything, because it would have to insert some subset of this into every time it's used, or put it in some sort of method that has to be called very slowly.
Look,
I say very slowly, it's probably just about as fast as doing it in the interpreter, but it's slow compared to everything else going on.
I could put this down to here. Yeah, okay, I'll reorder this to get it so we're not waiting for the Cordic any longer than we absolutely need.
So in some cases, it might be better to actually, instead of doing the QMAL get QX, it's sometimes actually faster to fake the multiplication with a bunch of ALU multiplies.
Yes, yep, I thought of that. But here's the thing: we can't do a 16 by 16 multiply because one of our terms is 20 bits.
Yeah, but you can take. It takes a couple of moves and shifts, but it's faster. And I think if you do 32 by 16, it's still faster.
Yeah, Yeah, it would take a little more code, but yes, it could be faster than this. Because this is going to take like 65 clocks, I think, right? Or 66. 32, yeah, I think 66 clocks, I believe. Yeah, I thought of doing some kind of manual multiplication using the mul instruction, but I didn't break it down.
I
But
have to think about this, because now I'm thinking about this. Since there are some cases where it is faster.
well, yeah, I mean, you
Sorry,
could
I'm just thinking about the funny flex bin optimizations again. It probably is. We're currently doing always QML. In some cases, it would be faster to do the multiplication inline at the cost of the code being larger.
right. Think of this.
Just random thinking. But
You have a 20-bit
Really
address
implement.
space in bytes. You have a 20-bit byte address space, right? And then we have a 3-bit within each byte. So we really have 23 bits that we have as a potential index if you're starting at hub location 0, bit 0, right? There's 23 bits of index in that case. So we have to do like a 24-bit, but this is only a 6-bit value. So we really need to do a 24 by 6-bit. We could just longhand that, you know?
if you set the index into the top of the long and then do like some sort of shit multiply.
It's just a rotate and add, a rotate and add, a rotate and add. So your pop or a shift left add, shift left if C add, shift left if C add. We could do 12 of those, but the trouble is we do 6 of those. It'd be 12 instructions, 24 clocks, but we may not have more than those number of clocks left when we get down here anyway with the Cordic, and this would, I'll have to figure out how that would work.
That's the funk, most certainly.
Yeah.
The big funk.
What I find myself doing, this chip, I have to slow down to program it because there's many, many ways you could get something done. And it's like you're suddenly playing chess all the time. You're not.
Have you ever realized that there's instructions that are completely redundant?
Yeah.
There's opcodes that are redundant. In particular, all the test opcodes with or and flag values. I think there's not a case where that couldn't be encoded by the condition code. The XOR, yes, the XOR is important, but the AND-C and OR-C or that sort of thing, those are actually redundant, I'm pretty sure.
Let's see. Because you could use conditions to compound values. Is that what you're saying?
Yeah, you can use conditions to do pretty much the same thing.
No, I know what you're saying. I think though there are some, because I've coded stuff before where I kind of was thinking that, and then I realized there is some value in having or C and C or W or Z.
The XOR-C, yes, the XOR-C is terrifically useful and very good, but the and or are not useful.
Yeah, I've thought the same things, but then I remember thinking that there was some case where they do have some utility.
I guess if you're mutating the condition somehow dynamically, but that seems like, when does that ever happen?
Yeah. I've hardly used those NC or C, X or C things. They're in there, but I don't know, maybe I haven't thought to use them, but I've never really used them for much.
I use the XOR-C because and the other ones too, but as I said, they aren't really needed in any particular case that I know of. If I go into one of the funny emulators, I can see how many XOR-Cs are in there. 13 apparently for the Mega Drive emulator. Here we've got one. I don't even know what that one does. Oh yeah, that's checking the condition. That's a smart one. On the 68,000, all the conditions, all the opposite conditions are adjacent. So there's odd and even pairs. So 0, I think, is true. 1 is false. So if always, if never in Propeller lingo. And then you have like if C set, if C not set, that sort of thing. So I have a lookup table of flag register values. It's a bit complicated to explain, but it's actually half an array because all the values are redundant. So I shift right the condition code 1, then I get it in the carry, and then I look up in the truth table. No, it's okay. I'm bad at explaining this, but it does use X or C.
Okay, okay, that's good to know.
And also because of another like weirdness, you know how these sub S and add S don't actually give you the overflow flag anymore. So you actually need test B31 XOR C to get the overflow flag.
Right. Well, there's also a test overflow and jump that does some.
Yeah, but that's even worse.
Yeah, it eventuates in a branch, not a flag condition.
I mean, again, this is also in the emulator for generating the overflow flag that the virtual CPU needs. So I'm just bit seeing it then into the status register. So it's one extra instruction, but it would be more extra instructions as it weren't for the XOR C suffix.
Okay. All right.
Anything else anything else funny? I mean, it shows up in a bunch of places.
Is there consensus on the use of the word field?
I mean, Eric said that if you have field as a variable name, then it breaks it. But actually, I think that could be disambiguated.
And we could use that.
I mean, any string of characters that you use could be a problem unless you put like 3 underscores in front of it. That's how the C people do it.
Oh God!
If you add some sort of new thing to stop it from randomly breaking your code, they put like 1 million underscores in front of everything.
I saw a C compiler manual once that had all these things, the underscores, and they published the manual in a variable space. Not a monospace? What do you call it, like a kerned font?
Proportional.
A proportional font, and the underscores ran together, and you couldn't even tell like how many were there.
I think 1 underscore is allowed for user symbols, but 2 underscores is reserved for compiler symbols. I think that's the rule.
Oh, okay.
But sometimes you get triple underscores in very interesting scenarios.
Observation for you. I think that while
I like bits.
while Chip is refining or growing the language, there's going to continue to be overlap with existing code. The underscores typically were reserved, but I'm not sure I'd want to see that in the main language as a requirement.
Yeah, and I don't want that either. It's horrible, but there isn't really a good solution to this problem.
Hey,
except I guess maybe the caret thing, but that's a bit. What does that mean?
Does when used the way when I popped into this conversation, I'm pretty sure the assignment line into P there was a caret X.
Yeah, it is.
Okay, and then is there any reason why the flip side of that couldn't be caret bracket?
Well, I had it like that, right? So it would be like this, right? The trouble is when you want to take an address of it, you got to type that, which looks crazy.
I mean, as I said, it does look like a funny smiley. So maybe that's just.
Does everybody know that caret at is a pointer?
I mean, there's plenty. If you're going to complain about weird things in the Spin language that don't mean what you necessarily think they mean,
that doesn't seem terrible.
I don't think that's where you start.
All right, and you could also disambiguate with parenthesis, I'm sure, right? So
no, parenthesis means that you're going into like a sub. You could, well, let's see, a parenthesis. Now, parenthesis could just mean a sub expression.
No, I'm not saying as a solution to the problem. I'm saying to the existing line before, you could probably do caret at parenthesis, right? And then
yeah, like this.
If not there, below. on the reference below.
Oh, like this.
Yes.
That,
I mean, that would probably run out of the box, right? If caret meant what it does or whatever. Or
yeah,
meant what
it would.
meant.
Let's see.
I'm not
Yeah.
saying you have to write it that way. I'm saying if the author chooses to disambiguate it.
Yeah, that wouldn't work the way I run the compiler, because that would descend to another level of recursion, and it would lose context. It
I
kind of
see.
needs to be all at once.
I see.
Well,
Well, that wouldn't break. I mean, that the syntax there, I don't believe breaks the language, and
no, that'd work.
at least, and it's certainly reflexive of the line above. I mean, like that doesn't
Right.
strike me as crazy hard to follow, especially at the level of detail and all of this discussion happens at. I mean, if you're writing near assembly language, then like, yeah, like you have room for confusion.
I mean, spin basically is just glorified type things and bytecodes happen.
Yeah.
See, doesn't that look pretty nice? That looks like very simple. But then the trouble is when it's on its own, then it looks ambiguous.
Right.
I mean, I'm not, I said the funny smiley thing is it's not that bad. I don't think it makes sense from a sort of orthogonal perspective.
Yeah.
And how often do you really write that?
Right.
Like, it's not that bad.
And see, if you ever wrote this, now here's like the compiler semantics thing. If you ever wrote this, you know what the compiler would see?
I would think the way you defined it would throw
see a one-eyed person squinting that eye and putting out their tongue at the same time. That's what the compiler sees.
Let's see. At some point, it could look like an XOR.
Right.
Oh, because you also use that for XOR.
Yeah, that's an XOR like.
That's unfortunate.
Yeah.
We need to invent a new symbol.
Yes, this is the whole problem. 7-bit ASCII is wonderful because you can do anything with it. But for efficiency, it would be cool if you could just sort of magically make new characters as needed, that would give context to like what something means, and get around having to use combinations of non-symbolic characters to mean things.
In like Unicode?
Right, but not Unicode.
Unicode
makes head hurt.
Does
Well,
expand.
Unicode made hex hurt makes head hurt if you actually care about the individual characters. If you just have an UTF-8 string and just treating it as like a string of things, then it's not that bad. Until you have to render it, and then it turns bad again.
Depends on the tools you have, I suppose.
True.
So
I mean, it's certainly better than what happens with shift-JIS, because that has the very funny property that the continuation bytes for multi-byte characters can themselves be bytes that are normal ASCII characters. So if you search for an E, maybe search all E's in the file, you'll get matches inside a character because.
Oh yeah, because it was like an escape sequence.
And UTF-8 doesn't do that. All the extension bytes are in the top half, where they don't match with the single characters.
Well, look, guys, what would you rather live with? 1, 2, or 3?
I mean, 2. 1 doesn't make any sense. I think it's either 2 or 3, and 3 has the thing that it's that it takes up a keyword in the semantics. Someone might have a value called field already. That seems relatively common, but then again, changing it is not that bad.
No, I think we have to make a decision, Chip. You have to make a decision sometime in the development of this language that you're frozen the use of terms, and then you won't affect code that's already published.
Right.
I don't think you have made that decision yet, and so I'm okay with your doing things. We have seen when you added floating point, the ramifications of interference with existing fielded code. So we understand what it means when you field a new symbol. In terms of 2 or 3, I could go with either one. I think 3 has better readability and teachability. I like the symmetry of 2. But anytime you, one of the reasons is it APL, people correct me, that were mostly single character symbol based, and people had a hard time learning it and internalizing it because of that.
This, yeah,
And
in
so-
chat, or, somebody pointed out that the more obscure the operator, the more important it is that it be readable.
Yes, yes.
And I think that's
I mean-
super, that's a great point that I
Yeah.
wish I had made myself.
So maybe a keyword or not, or do you guys like this? Because this does match this.
It does, but it's going to cause you more research and learning. It's going to cause you more time to learn the language.
Yeah.
And so there's a side of me that wants to err on, let's add a keyword. Choose it carefully and so it's symmetric with other keywords that you like to use that already appear in the language. So
I
it
mean,
looks-
yeah, the long
looks like it's part
bytes,
of
reg, that sort of thing, it's field is symmetric of that.
right. And so choose something that works.
Say that again, Ada.
And then we'll deal with the, we can rip through the OBEX, we can rip through the quick bytes and make changes if there are interferences there. And, put a warning in the manual that this is the new keyword introduction, watch for this. And that should be fine. If you're not at the place yet where you're ready to freeze the language, then don't freeze it yet.
Yeah. Well, use of this actually is kind of a new, it's like a escape hatch.
Right,
That's not interfering with anything.
correct.
Actually, this doesn't interfere with anything either. Neither does this.
Agreed.
But here,
Sure.
register byte word long.
Okay, that's
Someone was going to say something that hadn't spoken up.
Yeah, is field the right word? Is that too generic? Like, what exactly are you talking about here? And I missed that part of the
So
conversation.
you're talking about,
Bitfield.
look at this.
That's what we're talking about.
Yeah, see this .7, I mean, you may not always have a dot, but this end tail part says bit field. I want bit 7 through 5 of the 4th byte of,
And call it a bit field, not a field.
Right.
well.
And that's going to be much less likely to run into variables, I suspect.
Okay, but here's the thing. We might have something that just looks like, I mean, it could just be this,
Right.
right? We still want to call that a bit field?
Maybe.
Because what it does is it forces them to call it a bit field when maybe it's not really a bit field.
No, but it's the thing. Here's the thing, Chip. That I don't see how that's even relevant, because what we're talking about is the line below it, P and X.
Right,
Not
it'd be
I.
this, it'd be
Oh,
this.
sorry. Yeah, there you go.
Yeah, that's how it should be. It should be X.
Oh, okay. Well, that makes that code make a lot more sense to me now.
We morphed it out
The
of making sense. Sorry.
it's okay.
I mean, it could, here's a 4-letter bit
Isn't it?
F.
I mean, anything, here's my point. Anything that's a field is a bit field by definition. I mean, we're working in a binary system. So you can call the keyword whatever you want. Like this is bit field. So like the nice thing about bit field is, I think, again, it's just way less likely to interfere with existing code. And maybe it's adequate.
the obvious solution is, of course, to use something like zonk. Just use a word that no one has ever thought of using in a programming context.
I mean, but right. But what's the best context for it? And maybe, maybe the actual right word for this thing, maybe it's not field, maybe it's not bit field. Right?
Call
Like,
it
what
onken.
is
That's a word I've used in oh god. I'll tell the stories later, but onken.
The problem with number 3 for me is I look at that and I see a variable called bits. Like I don't see a keyword. Like keywords usually have white space before them or parentheses or something, right? Like that really just looks like, an array reference in the bit res.
Right, yeah.
I mean,
or bits is-
byte looks like that too, but byte is a keyword that's used somewhere else, I guess.
Right. In your documentation, you already talk about fields in a couple different ways.
Oh,
Yeah, well,
Yeah.
they're always bit fields, always
Right.
bit fields. Because this
So
could
that's
kind of
not
be a,
inconsistent.
but I mean, it could be a byte field, right? I mean, you might be talking about a byte field somewhere.
Well, even a byte field is still an 8-bit field.
But
Is
I
the-
let,
yeah, exactly.
being made.
yeah, but field is the common denominator. Bit is getting too specific because you might be talking about, 2 bytes.
Right.
And I like bit field. The trouble is it's just a lot of typing.
Oh my God. I didn't realize there was a shortage on type keystrokes.
Yeah. We got to conserve
mean-
memory.
Well, we have to chip it so
Yeah,
much fun because I
I
understand.
mean, most keyboards have a limited lifespan of how often you can hit the key. I haven't reached
it-
that yet with my Logitech cheapo, well, not that cheapo, but like medium range keyboard. I don't know
Is it-
what it
is-
takes for a keyboard to reach that point, but it will eventually.
Is the shortage of keystrokes somehow tied to the Ukrainian situation?
Oh yes, they're manufactured in Ukraine. No,
Yes.
they actually like. What? I think they make these cherry key switches. I think they actually are in Germany factory. They may have not outsourced it to somewhere else yet.
To your point, Chip, most of us use editors that do type filling for us. So when we type the left edge of that, it's already suggesting what the right edge is. So we aren't typing every character. So most of us don't think about the number of characters. Yes, it affects compile time, but we're also not going to care about that. So really what we want is for those of us that are staying away from these kind of issues, what we want is something that trains fast and reads fast, so that we can walk away from it, work in the other 8 languages we work in, come back to this language and still know what we're seeing.
Right.
So that's where my head is, and that's why I brought this up. I also happen to be the syntax highlighting guy, but that's, so I think there too simultaneously. But I'm really looking for how do we make this language strong and better training as the
Yeah.
primary. The second is, of course, highlighting. So I'm not caring about length. We understand that you're going to have overlap with terms. I understand your concern with field or bit field, but I think I'm in agreement with Tom here in that a field and a bit field are simultaneously the same thing when they happen to be on byte, word, or long boundaries. And so it is a bit field, whether it happens to fully match the byte, word, or long underneath doesn't matter to me logically. And so I'm okay with field, I'm okay with bit field.
All
I
right.
looked up synonyms for field,
Yes.
and there are some interesting ones, maybe.
Oh.
I'll read them all.
Mhm.
Clearing, ground, lot, not particularly interesting, I think. Parcel, plat, plot, and maybe very interestingly, tract.
Huh.
I don't think I've ever seen tract as a variable name in 42 years.
Oh, tracked. Oh my.
That's an
Yeah.
interesting way to get around the problem.
Good point, Tom. Tracked. Yeah, but it looks like
Right.
traction or something.
No, it's a tract, like a tract of land.
Yeah,
Right.
but someone might have used it as an abbreviation for traction.
because of the keystroke shortage.
Yes. Oh my gosh.
There's also, for the entire time I've been coding, been a tremendous shortage of white space as well. I should point
Yes.
out, like,
Oh my gosh, yes.
God forbid anybody use space or return.
I mean, we just had a major calamity in the forum with, gosh, missing new lines.
Missing new line?
I think I may have been part of that problem.
There was a CR only delimited set of files that I accidentally distributed, which actually affects the compiler negatively.
I was gone for a minute.
So who knows? So I was saying that we were talking about the white space calamity, and I said, well, we just had a line ending calamity in the forum with a BLDC driver. And so I just had to re-release files yesterday because
Oh no.
I don't know how that happened, but your compiler apparently does something differently when the file has only carriage return delimited lines, which they should never be anyway. But
How do you even get carriage return only?
none of us know, and I don't really want to spend a lot of time on
Well,
it.
I think old macOS used this.
That's
And like,
true.
I think the only way you could get it is if you accidentally clicked on the option to convert to that in like an editor. I don't know any other way that could happen.
Yeah, I have no idea how.
Then
So-
again, printing stuff on the propeller, it's usually the PST has a weird way of interpreting new lines. I think in that case, you actually do use CR only, which is mildly bizarre.
yeah, display output. Yeah.
And that sort of seeps into, oh God, I did a funny text driver for the P1 that basically sort of drop in for a serial terminal, like it does all the funny operations inside the same cockpit as the video.
Oh, nice.
And that has seeped into that now as well. So all the files that I want to display with that have to be CR only. I think how did I even convert that? I don't remember. Do I just keep them as CR only in the repository? I forget. It's been a long time.
Maybe not good. Anyway, Chip, did we answer your question on what you want to do? Do you have an answer?
Almost. Let me turn this share thing back on.
Because we should make you successful here by giving you an answer so you can move ahead.
Yeah, okay, hold on. Let me get back into this share thing. Here we go. Okay, what about mem? I mean, it's some kind of memory, right?
Yeah, but that seems like an awfully
That's
awfully
be used
likely
all
to
the-
become.
Yeah, agree.
It doesn't.
Do I use?
Aspect.
I would kind of, the keywords we're talking about, I think I'd maybe prefer just, I mean, what do you guys think about just a caret? Is this ambiguous?
I mean, it's unambiguous, but it's perhaps not as easy to look up in the language documentation. And that's what Stephen was on about.
Oh, yeah, yeah.
And if you look it up,
I don't mind
there's-
it, but other people very much do, I'm pretty sure.
If you look it up and come across XOR first, you're going to be very confused.
Right. Now, XOR shouldn't occur semantically at the stage the parser's at, right?
Yeah, but but a newbie reading code
Yes.
will not understand that.
Right, right. But this is kind of like,
Well, obviously, the newbie has read the formal language definition and has interpreted it in his brain and internalized it. Because that's what people do when they learn programming languages. They read the BPF formal definition. And then
I think the sheer number of
Which doesn't exist, Ada.
yeah, true to that as well. I mean, the closest thing to a formal description is like the FlexBin parser file, but that doesn't describe any of the lexing rules, which are bizarre. And that is a giant mess of weird things. Partially because some things it just in the parser stage it turns into like weird AST structures because I don't know, Eric was too lazy to add a separate AST for some things. So I think like the difference of sign extending between spin 1 and spin 2 is just handled by inserting a conspicuous +1 somewhere in the AST when it's passing the spin 2 version.
Chip, do you think we can move on to the file system progress, or is this part of that?
I think this is going to take a few more hours. This may never be resolved. But here's what we can do now. We can have brackets after any of these keywords, right?
Right.
So, it's a keyword or a caret or nothing. I kind of, the logical side of having nothing is that it could be any of these. So it doesn't need to specify that it's any particular one. Right? But I know that's ambiguous to read for someone.
Yes.
I mean, the no keyword might actually, I don't think it's actually worse than the caret for someone to read as a human. It's mostly just a bit weird to parse if you're not parsing from left to right all the time.
Yeah.
What,
It
yeah,
also
where-
doesn't just. Go ahead.
I was just gonna say, is the underlying value one of those? Is it a reg, a byte, a word? Or
Yeah, it is.
Okay. So hey, hang on.
Yeah,
So
see
what
up here?
about? Okay, hang on. Can we switch back? Like, what if all of those meant the same thing? But so, they would be like a new keyword, 4 of them, right? They all make the same code because it doesn't matter, if I understood you correctly. But then you would know what size field you were looking into, because you were talking about all these limitations on, this long, you can only do this many bits and all that when I first joined. This would kind of keep people, clear on what the limits are.
Yeah, but as you pass these pointer variables to subroutines, they may not want to know what they are, right? They just want to know that it's a field somewhere in register or hub space, and they're going to affect it in some way or read it. So,
Oh, I see.
because we're untyped, remember, we just have these values. We just have untyped values throughout this entire language, and it's all kind of what something is indicated or controlled by what operator you use on it, or it's only controlled by what operator you use on it.
I understand. And so this doesn't work in the case of a pass. I get that. And that's good logic.
I mean, that's just
Thanks.
a kind of weird thing with languages, that everything's like an integer. I don't think anyone else does that because it's kind of bizarre. It works in the case of Spin because it has an object type that kind of encapsulates things. But objects aren't values, which is again mildly bizarre.
Right.
I think if you made a compiler that's more complex, you could make it typed without having any particular, without having to annotate the types. As long as you don't want to have like small variable types, those you'd have to type out, like, is this a byte size variable or something? But like you can always discriminate if it's a pointer or if it's a pointer expression or a integer expression, right? Because that's just how pointers work, kind of. You kind of have to get them from an at or something like that, and then oh, that's a pointer. So you don't actually need to say it's a pointer. It's just that both programming languages are stupid, like C, and then you have to type that it's a pointer, even though the compiler could infer that's a pointer. In fact, C++ can infer that it's a pointer, but you still have to write auto because language compatibility. They can't just let you declare a variable like that.
So
What?
I mean, that's a way of doing it.
Yeah. Yeah, I mean, it's nice. It's a 4-letter word, like most of the other possibilities. No way anybody
Saves
uses.
keystrokes.
Yep.
I mean, auto may have been used somewhere, but less likely than field, I think.
But the thing is it's first of all,
What are
let's
we
not
trying to
make the
say?
language more like C++. And auto isn't it doesn't describe what it is, right? Like it's
Right.
yeah, that's like I understand how it's connected to the conversation.
Now,
The
Chip,
idea that the idea that it's indexable is a huge part of it, right?
correct.
Yeah, that's a big part of it.
Whoa, how about indexable or something like that?
Not
The
terrible.
keystroke shortage, you have to conserve
Not
them.
terrible.
Let's not remind
I'll
ourselves
take
we
it.
want to care about that.
It's too expensive.
No, that's reasonable. I'm still. There are lots of things that are indexable. I think bit field is still a better descriptor.
Maybe something like IX PTR or something.
Index pointer.
Was that- I'm trying to figure out if that was a parody or not.
If it was a parody, it would be something unpronounceable. Then, like, what are you talking about? Oh, I'm talking about the.
There you go. What would an IX pointer mean? Indexable pointer or something like that?
It could be a byte, word, or long.
Yeah, thank you, Chip.
It could be a bong. Yes, that's okay. Bong. No one has ever used bong as a variable name unless it's like stupid.
It's not descriptive of what it is.
Bong.
That's wonderfully
Sure.
misleading.
I'm pretty
Yeah,
sure.
wrong.
it
Wrong is
happened,
good. It's
but
it will
I'm pretty
confuse.
sure the code. I'm pretty sure that's been used as a variable name, but I'm pretty sure the code never ran properly.
If you use wrong, that will confuse all the evil Chinese communists
Right.
because they can't tell the difference. Ha ha ha! Very funny. And then they can't steal the
It's too
all
bad.
American technology.
I've been spending too much time with the Korean language. You're just cracking me up now.
See, var would be good, but we already use it as like one of the most important keywords.
I mean, is it valid in that case?
I still want to head towards Tom's point of let's use something that actually describes what it is we're doing.
Oh,
What it is-
PTRI, that could be good. It's maybe conflicting with the PTRA, PTRB, but the thing is, those are already reserved keywords. So the likelihood that someone is using PTR single letter is lower.
Oh, that's interesting. Please
That,
no.
that relates.
Please no.
Oh, it's type
Okay,
carrot
what if-
that.
What
No,
if we
like
did,
the word carrot. Like you have to type the word carrot.
okay, so what
An
if
ugly laugh.
we picked a keyword, but clandestinely supported this syntax as well?
Clandestine.
What do you mean? You're saying allow both in the language?
Yeah. That would just, no, that wouldn't be good, right?
Well, it doesn't help. I mean, yes, you could get there technically, but it doesn't help readability if you let us do things that don't.
I mean, secret language features don't seem like that.
Not trainable.
They don't. Then again, maybe it's like some sort of magic thing where you know about how like there's actually an incentive if you're working for like a company or something to write code that's terrible that only you can read, so they can't fire you, because if they did, their entire software would no longer be maintainable. You know, that's the exact perfect thing for that. Well, I say anyways, we let the SGDK cube example decide.
All right. Okay.
The cube says nothing because all the sides are the same, which I guess is
all right,
exactly what this argument boils down to.
we'll think
Moving
about
on.
it. Maybe something will congeal, and talk about it on the forum, but it's been good to discuss that.
It has. So the two favorites now are bit field and pointer I, right? And we'll just move on.
Okay, I'll write those down. Bit field and pointer I. Okay. Okay, so, all right, that's that. So I've been working on this file system, right? And we know that for a file system, you have to do some kind of where leveling, and you have to approach the thing with respect to what state the bits go through. Like in the case of a flash chip that we're using, you erase a 4K byte sector and all the bits go high, and then you can selectively program them to 0, right?
Mhm.
So to where level, Uh-oh. To wear level, we have to spread the usage around the chip. And the obvious thing is, let's say you put a bunch of files in your file system, right? And you have a little bit of memory left. Well, it's kind of natural that you think, well, what we're going to do is we're going to spread the wear around that new space, or that available space, because everything else is already taken. But then, of course, we get these hot spots, right? Because as the file system fills up, there's fewer free sectors and they start getting all the wear. So I had this epiphany one day about how to do this. Here's what it works. It turns out it works really well, and I'll have a program that demonstrates it. What you do is, we have, well, in my little test case here, I have 256 blocks, but in the actual chip, we have 4,096. Here's what you do. You use a random number to pick a block. Doesn't matter what the state of the block is. You randomly pick a block. Now, if that block is free already, you hand it off and the guy can use that block. If that block is in use, you copy that, you replicate that block into a free sector, and then you give that block to whoever's going to write. And it has the effect, does that make sense? It's like a big idea, but in a couple of words. So you always pick the only way you're going to get random wear leveling, the only way you're going to get good wear leveling is to have truly random sector picking, or maintain a database of the sector usage, right? Like, how many times has this block been hit? So we have a good random number generator. And if we can randomly pick sectors, the distribution will be really flat. The trouble is, some sectors are already in use. Like, if we pick a sector that's already in use, what I found out we can do is replicate that sector, because it's all ID based, not sector based, right? I'm using the word sectors and blocks interchangeably. Sectors is from the old days, blocks is from today. I'll try to use blocks. So what you do is you replicate a block with the same ID, and then you do this special crossover pattern to get it to safely transition to become the new ID for that new ID that's required out there that some block must have. Then you take what was the used block and you give that to the guy that needs to write a block. And so here's what happens. I have this little program here, and I write a bunch of files, right? There's enough room in this thing for 16 files. So I write 14 files and then keep rewriting one file. I do it 1,000 times. And what we do is we're going to track how much wear each sector got. So by using this idea that when this guy needs to rewrite, we're going to randomly pick blocks, replicate them into unused blocks if they're already used, or just hand them off if they're already free. So when we run this thing, watch what happens. Let's see. Okay, do you see the wear down here? This is like, now I'm modeling a 16 by 16 or 256 block file system here, right?
Good visuals.
And the red are the ones that are in use. No, the green are the ones that are in use. Red are free, unused. And then this is on a sector by sector case. There's 256 X points on here. Let me get this. Let me move everything a little bit. Oh boy, how do I get those guys to come back out? Let me rerun the program. Okay, so you can see these. So green is used, red is free. Should be the other way around for what we think colors would mean. But this is all the sector wear. You see that?
Mm-hmm.
So it's being distributed evenly across the whole file system. And anyway, it works. It's like a pretty simple concept. And now we rewrote the same file 1,000 times, which each time it ran, it took 1/16 of this whole file system space, right? So we're talking 1,000 by 16. If I calculate this, 1,000 divided by 16, we get 62.5. So this means that each sector should have been written over 62.5 times. And I'm not sure, it's about 4, we're hitting about double that, 120. Okay, so we're double like the theoretical minimum, but we're not any over that. And we don't have any sectors that are getting too much activity, and we're not getting, sectors that are getting too little. So the algorithm efficiency is that it writes on average a sector twice as often as it would need to be, but most importantly, it doesn't leave any hot spots in the map.
Now, Chip, to qualify your twice as many, you're saying twice as many only when you run into a used sector.
No, across all cases. So that's the magic of randomly picking a sector and going with it, whether it's used or not. So if it's unused, you just say, here's a free sector. If it's used, you replicate that existing sector with the same ID into some free sector. And then you give that used sector, what was used sector, you give it to the guy who's now going to use it for some purpose.
How do you
Right.
choose the free sector?
Okay, so there's a pool of known free sectors, right? There's 16 of them in most times in this simulation. And so what it does is it takes a 32-bit random number, and then it does a modulus of 16 because there are 16 free sectors. And then it uses that number to index into the free sector list to pick a sector. That way it's really randomly picking a free sector, not just the first free sector. Because if we pick the first free sector or the last free sector, or we tried to maintain a counter of where we were, because the counter becomes worthless as soon as you move anything around, right? So,
Right.
so it just statistically all works out beautifully without needing any kind of like database of, who's been hit how many times.
Right. The cool thing is while it sounds terrible that it's going to require twice as many writes as, the minimum, the thing is your where space is the entire thing, including the files that are never moved or written, like
That's
yeah.
And the advantage of that also is that, these chips have like a 20-year data retention expectancy. Well, anytime you copy a sector, you just refreshed it. So the more the file system is used, the more updated all of the sectors are, the fresher they all are.
interesting.
I mean, even worse, if you keep reading the same sector over and over, it's supposed to eventually give out.
Yeah, after 100, it says they're good for
Writing.
100,000 writes and erase cycles.
No, after a certain number of read cycles, it actually it doesn't destroy the sector. It just makes the data go funny.
Yeah, MRAM has like equivalent read and write life cycles, but flashes, you can infinitely read it. And
actually, no, you cannot infinitely read it. At least bare flash, I don't think you can. Eventually it will give out. I'm not sure if that's something that only like old flash does. That they fix it at some point. But it's called read disturb, and it's a thing that can happen.
Yeah. Okay, so well, I'll tell you what, though, we know it's probably 3 or 4 orders of magnitude higher than the write life, right?
Yeah, it's higher than the write life. And again, if you just rewrite the sector, it's fine again.
Yeah,
it's like the funny trapped electrons get out if you read the thing too much, something like that.
Yeah, so, okay, yeah, so read disturb is a well-known phenomenon in NAND flash memory where reading from a flash cell can cause the threshold voltages of other unread cells in the same block to shift to a higher value. So, okay, sweetie.
So this actually helps with that. Because if you read the same thing over and over again, the reads get distributed as well.
Yeah, it distribute. Although you might have
as long as there are writes going on as well.
Yes, as long as there are writes going on, you're refreshing the cells and you're distributing the readware. And once you reprogram a block, you reset the read disturb.
Nice.
I'm actually wondering to what extent like SD cards have protection against that. Because in my funny P1 stuff, I'll sometimes just read the same sector over and over again because it was the same like 4 sectors over and over again because the cache I have is only like 3 sectors. This is just reads the same ones over and over again because it's fast.
Yes.
I haven't destroyed a card with that yet. It may happen eventually.
I think read disturb, it's got to be like 6 orders of magnitude above the write cycle. You know, the write erase cycle. It's got to be way, way higher than that. But yeah, moving this will eventually cause even static data that's not moving off the disk. It'll cause it to migrate across the whole disk over time as you rewrite files. And then there's a special handoff technique where you know that you can program when you erase the sectors a block, all the bits go high, right? Well, we have like a one cold pattern, right? Like there's a special 3-bit field and everything's checksummed. There's a special 3-bit field in each block where one of those bits is going to be low. And so when you replace a block, you make a replica block, you set the checksum as if that one bit is set. And the very last thing you do is program the next bit compared to the prior block of the same ID. And so that one, that's either going to pass or fail, right? If it fails, your old block is still good and this block never became valid. But if that program takes, that means that this block is now both valid and higher priority than the block it just replaced, all by transitioning a single bit. So that's the
that's pretty good.
That's like the 2 magic ingredients that make this thing
What
work.
are you using to checksum the blocks?
A CRC32. And
yeah, it's right. There's instructions for that.
Yeah, I added a new spin
Because
instruction.
something like adding all the values up in something that's a reliability issue sometimes. Because sometimes the checksum ends up being the same for similar data.
Yes.
I mean, the obvious one, if you're summing up bytes and you're fixing like a typo that goes from where you've swapped 2 letters, the checksum doesn't change.
Oh, you mean in certain cases, you're not going to get a change.
Exactly, yeah.
Yeah.
Well, in this case, it's only for validating the data, in which case it's less likely. But
Yeah,
still
so,
CRC good.
Yeah, the first 4 bytes of a sector, or the first 4 bytes of a block, are the CRC32. And that is the CRC32 of all 4,092 other bytes, or 252 in my model. So it's, yeah, statistically like highly, Tom and I were first modeling this in Golang. And as soon as we got the CRC working, it's like all files start off invalid automatically because nothing just happens to pass that filter. You know, I mean, it'd be like really improbable. So there's some protection. So it's good for data integrity. On mounting, we recheck everything. And
yeah, the probability is like 1 in 2 to the power of 32.
Yes. Yeah, unlikely, right?
Yeah, but not as unlikely as if you'd use something like completely overkill, like SHA-256.
There's 2 to the 12th sector. So there'd be a 2 to the 20th chance that that would be 1 in 1 million chips with random data would have a single sector that seemed to pass the CRC that actually wasn't valid.
Yeah, well, I don't think the data that's the random data that chips default to is actually random. Not like proper random.
Yeah, well, it's usually, the chips usually come erased. But that's,
I mean, that too, but
4 milliseconds away. Or 40 milliseconds away.
I mean, 40 milliseconds, that's a lot of time.
Yeah, yeah, it is.
A lot of time where I come from.
Yes. Oh, one other thing. Do you see this here? This, yeah. Okay, so I added a thing to the debug display, the bitmap display, where you can use this keyword sparse. So rather than have pixels which completely abut, where you can't see the line between one pixel and another, what sparse does is it puts big dots in place of square pixels. So you can actually see them individuated, but you're only giving it like bitmap data, which is really sparse to begin with.
Fun.
Does that make sense?
Think so.
It just lets you see every pixel. Whereas if these were squares, like this would look like a line, right? These two together would look like a line. These would look like two squares touching on the edge. So this way, for something like this, if you want to be able to see every pixel, it's a nice way to be able to see every single pixel in isolation without, and you say that you can count over and go, is that the 10th pixel? You can't know that if you're in a field of solid abutted squares. Let's see. I have a list here of, okay, so, all right, the other spin features I put in, let's see. I have this get CRC where you give it a, like a pointer to a beginning of a byte stream. You give it your polynomial and then the byte count, and then it initializes the polynomial to the bit size and then runs the whole thing and returns as a function the CRC. So this works with 1 through 32-bit CRC polynomials. And then string copy, this just copies a Z string. You could have done this before with like string size, nestled inside.
Bad. No, don't do this. Don't do this. It's bad. People have confirmed it is bad to do this. This is what C does by default, the old sort of way of C, and people have corrupted memory of this ever since memory existed.
Because they don't hit zeros and they just wipe over everything, huh?
Or the input string is longer than the destination. What you want is to add a third parameter that's the length of the destination buffer, and if the source is somehow longer, you have to clip it.
Okay, good idea. All right, I'm going to make a note of that.
Don't copy the bad idioms from the 60s.
All right, we're modernizing as fast as we can. Let's see. So I'm going to make a note of that. So this is going to be string copy is going to be destination source max size.
And make sure that the last byte of the destination buffer at any point then ends up as a 0.
Yeah, good idea.
Because then the next time you're copying it somewhere, it's going to copy all sorts of garbage data afterwards if you don't.
Right. Okay. Make sure. Okay. To place terminating 0.
And while you're at it, I'd add a concatenation operator that works in the same sort of way, but it skips to the end of whatever is in the destination first.
Okay.
String append?
Yes, string append. I think C calls it stircat, or sterncat if you have the version with the count after it.
Yep.
Okay.
Stircat works fine.
Yeah, I'll probably, as I write more code, I'll probably realize we need to do that. Okay, so I'll fix that thing up. All right, very importantly, GRAY will now be supported along with GREY in the color list.
Wait, it did not. So it only. Which one is the British and which one's the American again? I always forget.
Okay, it was supporting the English, which I thought was the American, but the American is gray, so it'll do both now.
They're synonyms.
Yeah, and homonyms.
Ooh.
You now have to accept every alternate spelling of everything. Sorry, I don't make the rules.
Right. Okay, so I think that, I have, okay, let's see, I'll stop sharing this. The other thing going on here is we got these back. I don't know if you can see this very well, but this is the headphone board. It works nicely. So it uses some polymer electrolytics for the base. Like I think this is a 470 microfarad. And then these are, I think, 2.2 microfarad film caps that are in parallel. So this just gangs 2 sets of 4 IO pins together. So it gangs 0 and 3, just 0, 1, 2, 3, hardwires them together. So if you put them in 124 ohm DAC mode, it becomes 124, 62, 31 ohms net impedance. And then 4 through 7 become another 31 ohm net impedance thing. And then it goes right to your headphones. So if you got some nice headphones, you know, that are, these are good headphones, are usually about 30 ohms. So this is beautiful. It works really nice.
I mean, the real big expensive quality headphones, they often have a lot higher impedance on them.
I think it'd be 600 ohms. Yeah.
Yeah, 600 ohm crazy headphone where you like need.
Yeah, they want 20.
But I mean, if you have like an electrostatic headphone that needs like a big thing that needs like wall power.
Yeah. You usually have a transformer.
But that usually comes with the thing you don't need to make it.
We got this working yesterday. Can you see it? Okay, this is blurry, but you see that little chip there that's diagonally positioned?
Mhm.
That's a 4-channel, 32-bit, 192 kilohertz ADC. It actually works really well. So we use their kind of reference schematic to hook this thing up. So we have 2 stereo jacks. One is for 2 microphones, and then one is for 2 line-ins. But they can all be line-ins, but one of them can be 2 microphones because there's a special microphone bias circuit inside that chip that can drive these. So you can do 4 channels of 32-bit. It's like 100 and, let me look at the schematic. Let me look at the here it is. What is the, okay, so 96 dB plus 18 dB of gain. So it kind of has like the actual dynamic range of maybe a 16-bit, but somehow they magically get 16 more bits, which I can't know if they actually mean anything or not, but you get.
I mean, if you're capturing from analog data, at some point where do you even get all those bits from?
Yeah. Oh, it says that no, it's got a dynamic range of 105 dB. So that's 9 dB better. It's like a little over a bit. It's like 17 bits, but somehow they get 32 bits. Does anyone know why there'd be 32 bits when they've only got 17 dB of range?
Maybe just because 17 is like not a good word size.
Yeah, but I mean, they actually they give you 32 significant bits, but I'm thinking that the bottom 15, according to the spec here.
Maybe if you're like oversampling and then it maybe averages them together and then bottom bits start existing.
Yeah, I don't know. There's some kind of delta sigma converter. But anyway, we got this thing working yesterday. Michael or von Sarvash, he said he was pumping music in through this, and then he was outputting it on our headphone board, and listening to headphones. And he said it sounded just like perfect. Like he couldn't, there was no artifact that would indicate this was like a microcontroller or anything. He said it sounded really good. And if this headphone thing proves not to be completely good, we could always make a board with, a higher resolution DAC on it. But then when you get to the power stages where everything needs to become really high quality with careful circuit design, right now by having just the DAC pins do the job, we're getting around a lot of trouble. We have a power stage already there, and we can. I mean,
the trouble with the DAC pins is that it doesn't even do full 16-bit resolution.
Right. Well, it's only doing 8, but it's oversampling, right?
Yeah, but but you can't use anything greater than FF00. So it's actually, so if you send a raw 16-bit signal to the DACs, it will actually get clipped at the top.
Okay, my friend, but consider this. What if you had like a 20-bit sample and this thing is updating? I mean, let's say you're running at 256 megahertz, right? So you're getting a 16-bit PWM out every microsecond. But what if every microsecond you added 5 bits of LSB dither to that 20-bit sample and you output the upper 16 bits to the register of the smart pin? You would cause that lower level data to percolate out upwards so that you would be able to, it would enhance the dynamic range, but it would be over.
No, I'm not talking about the dynamic range. I'm talking about that if you have a 16-bit sample and you write it into the register, it gets clipped at the top. Because
oh, I know what you're saying. Yeah, numerically, the last 256 steps are not available because there's no room to wiggle in. Yes, I know. Yeah, so you're right. So that's
So it's technically only 15 point something bit resolution.
like 15.99 bits or something. Yeah, you're right. Yeah, but that's that not much.
I'd have to
it's-
actually calculate that. I think that's,
well, it'd be it'd be
I have to
255 over 255 over 256.
No, it's the
Times-
logarithm of
16.
the number.
It'd be 15.9375 bits.
Is it 937? I'm trying to calculate, but
Yeah, it's almost 16. But we could get, I mean, by just doing a little bit of dithering at, you know, over two.
actually, I'm
sample
getting
periods.
15.994.
Okay, maybe that's,
That's the 2's logarithm of
Yeah.
FF00.
I didn't do a log. I did a divide. I oversimplified the problem. Yeah. So it's almost 16. But just by doing like 2 microseconds instead of 1, where you do 2 alternating values, you've now added 1 more bit, right?
Yeah,
And so-
you can get more resolution out of it.
So if you do 4 of those, 4 microseconds of 250 kilohertz update, you can get 2 more bits. And then you do that over 4 pins, you get 4 more bits.
I mean, the other issue is that the PWM mode kind of restricts your sampling rates, and the noise mode is a bit noisy.
Yeah.
I think
Well-
both of these would actually be solvable problems. Someone in the forum pointed out that if you had used the sort of pulse density algorithm that's used in the P1 counters for the dithering of the DAC, it would have actually not had that problem. It would still have
Yeah.
that clipping problem.
Yeah. I'd like it. I want to spend some time and kind of get into that and try to figure out like subjectively what sounds the best. And
I don't think you can really tell at that point because it's like all in frequencies that are really high. So you have to have some sort of distortion that aliases it back down. And at that point, you've already lost the game. If something that's like at a couple hundred megahertz, it actually be more like some megahertz if you divide it. If like around 1 megahertz, if that aliases back into your audible range, I think you've got other problems.
my friend down the road has an HP audio analyzer, which I saw at Past Labs. They use that for their testing. I could borrow that from him, and that might be helpful. But I think we can get really good audio anyway, just right over the pins into headphones. The only thing that would mess it up is if we have some impedance issue with ground, which is, you know, leaking noise in at 60 dB down or something.
I mean, I've got a lot of noise when I on my P2 evals and P2 edges, but only if I plug it into the line in of my PC. I haven't tried anything else in particular, but that is a lot noisy. And if I plug in headphones directly, it isn't
Well, yeah,
noisy. I'm not
'cause-
entirely sure
well-
where that comes from.
When you go into your PC, you're creating a ground loop, right? Because now you're making 2 different system grounds common. And if you plug
mean-
headphones in, you're all local.
I mean, the P2 is already plugged into the PC. That's where it gets its USB power from, right?
Yeah.
I mean, the line in on these motherboard sound cards is always a bit noisy. Like you can hear the PC doing things in it when you like scroll certain applications. You can kind of hear it continuously redrawing the screen. That somehow makes a noise, presumably because it's writing to like video memory, and that makes a noise on the motherboard.
Yeah, what you're getting is a lot of, if you had a pure ground off of the regulator that feeds those set of pins, I bet that would go away. But because we have a shared ground on the module, all that current's flowing through ground, and that's causing local noise.
But I think SD card access noise leaks through regardless. I think some amount of SD card noise is always on the audio.
Yeah, it's coming from somewhere though. I mean, there's a path for it. But if you think there's a lot of current flowing on ground and it's modulating, right? As the ground current increases and decreases, it's causing like a local ground voltage change. And that translates as noise into outputs which reference ground.
I wonder how like phones and stuff avoid doing this. Like they have SD cards in them as well. And I don't hear noises out of my phone when I listen to music. So something clearly is done to isolate that SD card power from everything else.
Yeah, well, they probably just use like good ground star or something and don't have, I mean, you don't want to, if you've got a lot of current flowing through, let's say this is a wire, right? And there's a load out here and this is a central ground, you want to connect to this. If you touch this ground here, well, this thing's modulating. It's worse out here, but you're getting some of it here. So that's what I think is going on.
Chip,
Yes.
my voice is being heard.
Yeah, I can hear you. Yeah.
Okay. No, my microphone is the same old SHIT. I have a question, and perhaps you can answer. When the ground and the positive voltage enters the edge module, the ground is just connected to the board ground. I'm talking about the
ground plane.
The tree.
The whole back of this is ground.
No, yes, but you don't have separate tracks to bring ground and the VI, the input voltage, up to the regulators, then spread that connection to the board, to the plain ground. I don't have access to the.
No, it's not a perfect setup. I mean, because we have to go, we've got on the back of the board here, we've got 3 ground pins, which go right to the plane.
Yes. But those 3 ground pins are directly connected to the ground plane, or 1 or 2, I don't know, because that board is six layer.
Yeah, it goes across, and then it has lots and lots of vias everywhere that feed all of the grounds,
Yes.
pretty much in parallel.
Yes, but the main problem I ever used in my boards to avoid such kind of problem, to bring the input voltage and the ground up to the regulators, and at the regulators, I connected that point, a single star point, to transfer that ground to the whole board. In other words, the input ground at the connector only gets connected to the ground planes after it passes the regulator. So the ground plane never sees what is going on behind, unless you have, for example, connected the edge through a connector and derivate the ground in other point into the connection board. So you cannot, I believe Cluso did that kind of layout when he puts the input voltage and ground at one edge of the rectangle of his board.
Right.
And after the regulators, it distributes to the rest of the board. So in a certain sense, you avoid many points of connections to ground until the regulators acts. I use one image where the cow goes, the ox follows. Em português, onde a vaca vai, o boi vai atrás. Where the cow goes, the ox follows. So, if you follow the cow with the ox, all the noise will be in the paths the cow walks. And at the mate point, the regulators, beyond the mate point, you don't have any noise. But the
Yeah.
problem will appear again when you use an adapter board. Because if the adapter board shunts the input ground that comes from the input voltage connector, again, there is another loop into the adapter board.
Oh, yeah, and
Either-
then the adapter board could have things pulling ground current between you and the edge module, right? There's,
Yes, but you must never connect the input ground that came from the voltage source ground to the baseboard, to the adapter board. First, it needs to pass through the regulators into the edge module. Then they are spread like a shower and will feed all the circuits ahead. So if you look at the regulators, before the regulators, you have ground that is not connected to the ground that is after the regulators. Every noise made by the regulator circuits will stay behind that point. And after the regulators, you have the ground plane of the edge and all the adapter board ground that connects to any output circuit. Is another way to think about there must be a straight connection, not a shared connection. You can simulate that, but by putting many inductors connecting the input ground that comes from the edge connector to the board ground. But you need inductors in parallel, and you need to a analyzer that shows what kind of noise is passing to the ground. And insert a bunch of high-speed capacitors to clean up the signal. It's another way to do the same thing. Only DC will flow through the inductors, and the capacitors will clean that signal. Ground versus ground, but one is input ground, the other is output ground. And the single point of connection lies under the regulators. This is a way to see that kind of connection. My main problem when I analyzed the edge board was the number of connections. You have only 8. If you had, say, 90 or 100, it will be very, very straightforward to connect 5 grounds and 3 or 4 input voltages through, so to alleviate the impedance in series caused by each connection blade. So you can diminish the difference between the input ground and the ground that finally reaches the regulators.
man, can you look at our, I can send it to you. Michael has it. I could probably get it off the site, but the layout for our current P2 edges, they're all kind of the same. We made them super low impedance to try to just, beat these problems, not through order, but just through brute force. But I'd like if you could comment on that.
Yes, because the main problem, every noise that comes from the connector, from the edge connector, if you share that noise along the path up to the regulators,
Yeah.
every noise that enters will be translated as noise at the ground pad of the propeller. even the noise caused by the switching circuits that are ahead of the board, driven by the output pins of the propeller. The main desire, the main idea behind is avoid to share the noise from the input circuit with the output circuit.
Yes.
In that sense, you will have cleaner clocks, you will have cleaner ADC and DAC circuits, because they have a reference that is only affected by the ground bounce at the propeller.
Right.
And ground bounce, that is a new type. I need to share a copy with you all, including Michael. There is a new compound that can translate holes in the thermal pad into copper that must be applied and cured before you assemble the propeller. And you can have vias with 4 millimeters in diameter, and those vias will be turned into pure copper. It's a new product. It was developed a year ago, but the problem of the pandemics have limited. They are being used in medical equipment, in rocket circuits and missiles. I don't believe that type of product is very cheap now, but it's a great idea because you pick the board as he went to you. It must not have a Haslow finish. Needs to be copper, pure copper. The vias and the holes needs to be pure copper. Then you use that past over with a spring and cure at 200 Celsius during half an hour. Then that part of the board transforms in pure copper and can spread heat and current like no other technique, unless you use a copper coin that's much more expensive. You can put a copper coin behind the propeller, but it will create a board that is too higher price.
Yeah.
And that technique of past and a cure of 30 minutes will bring a pure copper surface behind the surface, the propeller, almost up to 4 millimeters in diameter each of the vias. So you will have no problems to heat spread, nor problems with series resistance in transferring the ground from the board towards the heat spreader that is also ground in the propeller. And not a cheap technique, but way more cheap than using a copper coin.
Yeah.
So the main idea I was talking about is perhaps that it's possible to avoid to contaminate the ground planes of the edge with noise that only flows behind the regulators, and let only the noise generated by the propeller itself and the other circuits after the regulator contaminate the ground.
Yeah.
Oh,
All right.
thank you.
Lot to think about. Okay.